The broadcast is now starting. All attendees are in listen-only mode.
Welcome, everyone. My name is Terry Erzman. I'm the Chief Marketing Officer for Percona, and I'll be your MC for today. Today's webinar is Migrating to XtraDB Cluster, and that's for the 2014 edition. This is an update of a previous webinar. So I hope that you enjoyed today's presentation by Jay Jansen, who is a Managing Consultant here at Percona. Before we go too much further, if you can hear me, would you please raise your hand? Let's make sure everybody's got good sound. Okay, I see lots of hands going up. Thank you very much. If you have any questions today, we'll have some time at the end to answer those. Please enter those in the questions box in the GoToMeeting or into the GoToWebinar control panel, and we'll answer as many of those as we can. If we can't get to your questions, Jay will follow up with a blog post following the webinar to answer any unanswered questions or to offer any further clarification. With that, I will turn it over to Jay and enjoy today's webinar. Jay?
Thanks, Terry. So as Terry said, this is an update of a webinar that I actually gave over 2 years ago now, just as we were getting started with Percona XtraDB Cluster at Percona. And this update really is a bit of a revision because we've really had a few years of production experience, customers installing it, using it, the good, the bad, the ugly. And so I tried to really revamp it to get it up to date with some of our latest advances and our latest, production know-how and knowledge with the cluster. So that being said, really the focus of this webinar is to help people have an introduction to Percona XtraDB Cluster specifically, but Galera in general. What does it mean? Is it right for my application? I've had this discussion with an innumerable number of customers over the last few years, and this should hopefully help you walk away not necessarily knowing all the details of everything, how it works and how to operate it, but at least giving you a high-level overview of the types of things you're going to want to think about, going to want to look at, and a little bit of the mechanics of how the system itself works. So with that, let's jump into just an overview. What is XtraDB Cluster? Well, it's Percona Server plus Galera. Percona Server is of course, our fork of MySQL, community MySQL, and that has performance enhancement patches and so forth. And then Galera is a synchronous multi-master replication library that a company named Codeship implemented with support from MySQL and specifically InnoDB. So what is it? What does that really mean? Well, it's a cluster of InnoDB nodes is the way I like to think about it. It's really designed to work with InnoDB specifically as a storage engine, and that is due to its InnoDB's transactional nature. You'll see a little bit of that as we go forward. All the nodes in the cluster are readable and writable, so you have all this data, all these tables on these nodes, and you can read and write to any node you want to. It's something called virtually synchronous. I'll talk a little bit in the next slide about what that means and how that may be different from other synchronous replication solutions you've seen. The important thing, though, here to realize is that all the data is on all the nodes. So really, this is a redundant copy of the data across, in this example on the right, a 3-node cluster. So this is, in that sense, a little bit more analogous to a master-slave setup where you have the same data on your master and your slaves, and it gives you redundancy, scalability for reads, and so forth. The cluster, when it's established, so if there's a cluster established between the 3 nodes in my diagram here, it's responsible for synchronizing new nodes that join the cluster. And the cluster does that itself. So whereas in standard replication you have to go clone your slave, that's not something you have to do in the cluster will manage it for you. And this uses a process called state transfer. I'll just give a few more little details there we'll talk about in a bit. There's something called the donor node that basically contributes a backup or maybe just an incremental set of what changed to a new node joining the cluster, and there's terms SST and IST. The cluster itself also handles node failures and split brain scenarios itself. So if a node gets disconnected, the cluster is responsible, the rest of the cluster is responsible for evicting that node. Split brain scenarios and so forth are handled internally by the cluster itself. And more on that in a bit. So what do you what are some common questions that I get about XtraDB Cluster, you might be wondering. First and foremost, the cluster will work in tandem with standard replication. So any node in the cluster is still just a MySQL server, and it can act as a normal asynchronous slave or asynchronous master, just like anything else. So the diagram on the right, we can see, replication going into a cluster and coming out of a cluster. This is not a write scalable cluster. And what I mean by that is there's other products out there with the term cluster in the name that you add more nodes to the system, the data is actually partitioned across sets of nodes, and throwing more nodes at the problem gives you some measure of linear scalability. That's really not what Galera is designed for. As I said, all the data is on all the nodes, and so adding more nodes can give you read scalability, much like if you were adding asynchronous replication slaves to a master, but it doesn't give you write scalability in the way that other clusters might do so. The cluster really does work well both in LAN and WAN architectures. The nature of the replication makes it lightweight enough that replicating across country, across the world is only as bad as it has to be and not a lot worse. MyISAM is definitely not recommended on the cluster. You can get away with maybe a few tables that are not being updated very frequently, but in general it should be avoided. MyISAM will never have good Galera support because it's simply not transactional. One thing that people maybe aren't asking about but start to realize once they start operating a cluster in production is that the cluster is a lot more sensitive to every node that's a part of it than you're going to be used to if you're coming from a master-slave environment. In a master-slave, you can really do whatever you want to the slaves, and they may get behind the master, but the master isn't really affected directly by them. But in the cluster, that is not true, and there's a mechanism built into the cluster called flow control. That's job it is to ensure that no node lags too far behind. And if you're wondering how nodes can lag in a synchronous replication solution, I will talk about that in a moment. Also, though, writes that hit any node in the cluster are integrated with replication. Replication blocks those writes, and so every node must respond to a write, and therefore, specifically a commit, and therefore, if a node is misbehaving, you can have issues even just trying to commit a transaction if a single node is behaving in a flaky manner. Another thing that people don't typically realize, or they ask about at least, is does the cluster manage a VIP, or does it have some kind of connector or something like that? It does not. The cluster itself is responsible and designed to manage the cluster. The mechanism that you might choose to use or not use to manage the high availability between your application and the cluster is an exercise left for you, and I'll talk about some options and some details about how that works a little bit later in the talk. So I wanted to, and this is, if you've talked to me before about Galera, you probably have gotten the 5 or 10 minute lecture on Galera replication, what it is and what it isn't, what it does. But really, that's probably too detailed for this. Instead, I wanted to just give some characteristics of the replication to help you try to understand it, even if you don't know all the details. So the first thing to realize is that when if a client commits a transaction, and if this could be an auto commit, or it could be an explicit, begin statement commit transaction. If the client gets an OK back from that commit, what it means is the following. It means that transaction has definitely committed locally on the node the client is connected to. It means that all the other nodes have the transaction and have acknowledged it. And it means that the transaction will commit on the other nodes. It just doesn't mean that they have committed on the other nodes yet. So again, how is this synchronous? Well, think about the situation where you're potentially writing to multiple nodes and you're modifying a record. If I commit on one and it isn't committed on the other one, and I try to write on that other one, I can potentially commit something that's conflicting. The thing that is virtually synchronous about Galera is that even though conflicts are technically possible because of the fact that apply is not synchronous and commit is not synchronous on across all the nodes at the same time, it won't allow the client to commit conflicting transactions. So conflicts are possible, but they are prevented by Galera itself. And it's not something that's handled in the back end by the replication mechanism, but it's handled by pushing the problem back to the application. And that process, at least part of that process, is known as certification. So, and as far as the client is concerned, it comes back, a conflict comes back as a deadlock error. So the client, tries to commit something that's conflicting with something that was recently committed somewhere else in the cluster. It will get a deadlock error and not be permitted to commit in that instant. And then it's up to the application what to do, maybe retry or whatever the proper handling may be. So that's a little high level about what it really does under the hood, but it's important to realize that there are possibility of conflicts and the application is expected to deal with them, which is frankly contrary to almost every other cluster and data cluster I've seen. They always try to solve that in the back end somehow. So additionally, Galera replication, node communication is very efficient. It's really just a single round trip effectively. So if you have a cluster that's spanning the North America, you have probably somewhere between 80 and 100 milliseconds of latency between your nodes. A commit will take approximately that 80 to 100 milliseconds under normal circumstances. So whereas if you are thinking of a system or a synchronous replication system that does synchronize commits across multiple nodes, two-phase commit systems and similar, those are extremely expensive across the network, many more times than one round trip. And so Galera's big advantage is that the replication is very efficient, but it's implemented in such a way to avoid a lot of that network chattiness. Okay. So if a transaction is delivered to a node, that's enough for that local node to know whether or not it should or should not apply that transaction. The certification process happens on all the nodes. They don't have to communicate with each other about whether or not they're going to or not going to commit the transaction. All that information is contained in the process of replication, and each node independently but deterministically certifies and makes that determination independently. So again, it's a little unusual compared to conventional synchronous systems. So taking that and jumping it into some application-specific focus, your application working with the cluster, why do you care about replication? Many developers do not want to care about how replication works, they just want it to work. And my experience states that you always have to understand something about replication to build a successful application that uses replication, whatever the flavor is. So from the application side, conflicts mean deadlock errors. I said that already. But those deadlock errors, specifically that are replication conflicts, only happen if you are writing to multiple nodes in the cluster simultaneously. Specifically, they happen when you are writing multiple clients are writing to the same set of data or row or tables, some small set of data at a high rate across multiple nodes simultaneously. That's where those conflicts will come from. If you're running on a single server and only on a single server, you won't get deadlocks. But realize that commits will take longer than they do on a standalone system. Because replication is a part of the commit process, the commits, and while the commit process is happening, the transaction's still open on the source node, and the locks are still being held in an ODB on that node. Everybody else is going to have to lock wait, waiting to modify, say, the same record. So replication and also local certification must happen on commit, and that's more time than a conventional MySQL NODB server takes to commit. So another thing that isn't necessarily obvious, but if you think about it a little bit, because of the conflicts and because the fact that we can really only commit that row and get it replicated on a single node at a time, what that effectively means is a given row, any given row in your database, can't be modified more than one time per RTT. And when I say RTT, I mean round trip time, basically between any of the worst nodes in your, whatever the worst nodes that are furthest apart in your cluster are. So going back to take this to an extreme in the WAN cluster example, if you have a cluster that's spread across North America, East Coast and West Coast, then, and it takes 100 milliseconds for a round, ping, roughly a ping to go there and back, that practically means that any given row on your table, you can only update 10 times a second successfully. That may or may not be a problem for you, but it is, those kinds of frequent updates to rows might be issues that you run into if you migrate to Galera, particularly if you're updating at a really high rate relative to the round trip time between your cluster nodes. So actual workloads that are hitting the cluster, what are some successful characteristics of those workloads? The first is that they're running small transactions, meaning transactions that modify small amounts of rows. If you have a large transaction that modifies many, many rows, update, table, delete everything older than 3 months, and it's, 1 billion rows, and that's a single transaction. If you did that on a master slave, you would expect that the slave would become extremely lagged while it was trying to apply that transaction. And that will be the case also for the cluster, except remember that the cluster is sensitive from a replication perspective. And so when that large transaction gets replicated just across the network, and then it gets applied on every node, all the nodes will start to back up, and the further replication can't happen until that one goes through. This catches a lot of people, and it's a little different. It's different than master slave, but it's really the same problem as standard asynchronous replication. The slave does get quite far behind in this circumstance. Usually you just don't notice or don't care. The cluster will not tolerate it. So small transactions are definitely very important. DDLs, by DDLs I mean data definition language. I mean create tables, alter tables, and those sorts of things. By default, if you issue a DDL on a given node any node in the cluster, it will block replication and apply that DDL on all the nodes simultaneously. So and the reason it does that is so that it can apply it consistently on every node and be sure that the results of the DDL, the resulting table, whatever you did or created, is created consistently. So for a short-running DDL, just creating an empty table, that may not be problematic. But for a long-running altered table, that might definitely be problematic. So there are ways to work around that, but you want to be very careful and understand how DDLs work in PXC before you go forward. At a table level, you want your tables to be InnoDB, as I already said, and then also all defined with primary keys. That is a general recommendation for InnoDB in general. It's also a very strong recommendation for row-based replication in MySQL, which Galera and PXC rely on. And it's also just good database practice, to be quite frank. So those are strong recommendations for your tables. And then also, I just want to mention that we in Percona, and I do a lot of these, and guys on my team, we do PXC workload analysis for people who are considering moving to the cluster. And basically, the one sentence summary of what that is we're taking Percona server, a standalone master, enhanced slow query log, which has metadata that we need to do this analysis, and we do a series of PT query digest runs that's part of the Percona toolkit. And from that, we can find things like large transactions that might be happening, whether you're aware of them or not, DDLs, go check the tables, those kinds of things. So that's something that we do for folks, but we'll be happy to even just talk you through the types of things that we look for if you're not sure what your workload is like. So kind of going back to the fact that the cluster doesn't manage its own virtual IP or have any kind of connector mechanism, you still need to figure out how you're going to connect up your application to the cluster. What's the best practice and how to do it? I'll talk a little bit more about some of the mechanical things, tools that you can use and that are popular to use a little bit later. But for now, from an application perspective, I would break my recommendations up into writes and reads. For writes, it's usually easiest, especially if you're migrating an existing production application into the cluster, it's usually easiest if you start writing to a single node in the cluster. So if you have master slave in your existing production setup and you already have split read-write and read-only database handles, then it's really easy just to flip into the cluster and continue that methodology. And the reason why I say it's a best practice to start that way is because moving to multi-reader, you may expose hotspots in your data where there's a high likelihood of conflicts, and if you're not sure where those are, you don't want to migrate to the cluster and have to deal with all of those right up front. It's usually easier to sort of migrate over in a master-slave fashion and then gradually move to multi-reader over time. If you're building a brand new application or something that's starting from scratch, I would say that it's okay to start with multi-node writing because you're probably building it organically and your traffic's not going to get too high too fast. But realize that hotspots could become an issue down the road, and you want to be prepared for that. It's up to you whether or not you want to plan for the possibility that the cluster may not work out and you need to move back to master-slave. For reads, it's, as I said, very much like master-slave in the sense that you can just load balance your read traffic across all the nodes fairly easily, and that could be a subset, that could be all of the nodes, and so forth. No problem. Now notice that there is still replication lag that can happen, apply lag, but typically speaking, especially by default, that lag is always going to be lower than asynchronous replication just because of the way that it's implemented. So I also should add that it is possible to instruct a single connection, or you can do this globally, to implement something called causal reads. And what that really is the ability for the system to do a consistent read regardless of which node that it comes across. And that can be turned on a per session basis if your application is aware that it needs to be a critical read, or it can be just turned on globally, although realize reads, the read performance, the latency for reads will generally suffer as a result. Now, it's also really important, just from a high level, from an application perspective, to realize that you need to be sure that the nodes that you're connecting to are actually functioning members of the cluster. Just testing, if you just get a 3306 connection, that's not enough. The nodes can be in various states that are okay to read or write, or not okay to read or write. There are certain cases where you'll get a connection, but you won't be able to read or write. And so it's important that you understand that just putting a list of IPs in some simple application database library that just are round robin through is probably not going to be sufficient. You're going to need to do some extra health checking beyond that. So kind of with that in mind, let's talk a little bit about node failure and split brain and how that works and what are some of the implications of it. So in a standard cluster, again, going back to our 3-node cluster with nodes A, B, C, let's say C stops responding to nodes A and B. Let's say it crashed, the kernel panic or whatever. So node failure in this case, in all cases, is handled via a timeout. And because writes are waiting for a response from all nodes in the cluster, that means that functionally, when a node does fail, that the writes on the cluster will be blocked waiting for that timeout. The default timeout is 5 seconds. It can be tuned. But typically you don't want to go a lot lower than that because you don't, at the risk of increasing cluster instability. So we have a timeout, and when that timeout is exceeded, the cluster, the remaining nodes that can talk to each other do a quorum vote. They realize, well, we had a 3-node cluster. Now there's 2 of us left. Are we quorum or are we not? Now quorum is defined as anything over 50%, but not including 50%. So what that means is, in our situation, we have 2/3 of the nodes, and so A and B will continue as what is known as a primary component. As soon as they realize that that timeout has exceeded for node C, they will start this process of evicting node C from the cluster, and in the meantime, they will continue to take writes only that are only acknowledged on both nodes A and B, but not acknowledged, of course, on node C. Now, if hypothetically C wasn't actually down, let's say that the network was disconnected, or the connectivity between A and B and node C was broken, then that node would still be up, and it would also do a quorum vote. The quorum, however, in that case would fail since 1 out of 3 is less than 50%, and that node, or if there was a series of nodes in that that component without quorum, would move into a non-primary state and would simply refuse to read or write any data. Now, what that means is you can get a connection, but it will return an invalid command error every time you try to do a select or insert or update delete. Now, that's why it's important to ensure that your application or whatever manages the application to cluster connections understands that nodes could be in different states, and it needs to check that. Also, note that if C is disconnected, let's say it's disconnected for 5 minutes, and then somebody realizes their mistake, plugs the network cable back in, C is still running, and as soon as it rejoins, it will try to do one of those state transfers from A or B, and if that's successful, node C will just rejoin the cluster automatically. It's actually quite elegant when you see it happen. So, but that's basically how node failure in general is handled in the cluster. Now, as far as the question comes up, well, what about node counts? How many nodes should I have? Well, because of quorum and because of the greater than but not including 50% rule, you really need to have at least 3 nodes in the cluster for proper automated failover. Now, that may be inconvenient for you, and if that is the case, then something called the Galera arbitrator may be useful to add that odd node for you. That's a Galera functioning member of the Galera cluster, the Galera group, but it does not run MySQL. It does not actually store any data. And so you could have a third one that's your arbitrator. But realize if you do that, that having 2 data nodes, only 2 data nodes, can cause some issues when one of them needs a state transfer. So if one node is in need, data node is in need of a state transfer, and it has to get it from the cluster, and there's only one other data node, that other data node must be tapped to do the state transfer. And for a full state transfer currently, every state transfer method, SST method, is blocking in some way, including extra backup. Now that hopefully will change in the future, but currently it will block. And so in a 2 data node cluster, you may have some issues there. So at least rated 3 data nodes are recommended for that reason. You don't have to, but it is recommended. Now, Galera replication performance does decrease as the node count increases. In the default configuration, the network communication is unicast, and all of the replication has to be sent to each node in turn. So, but practically, you know, we're talking. I've done tests with a very large number of node clusters, like say 20, and I can, you can see a nice slope and kind of predict where it's going to go. But practically speaking, on a 3-node or 4 or 5 node kind of cluster, those are the most common ones that I've seen. And I've seen, I think, as many as 6, somewhere between 6 and 8. I recall seeing, but it's not. Typically we're not scaling beyond that. And if you're scaling beyond that, you probably should invest in a caching layer, because typically speaking, this is analogous to just having a master and like 20 slaves. That's a lot of slaves, and you can usually get a lot more bang for your buck by implementing something like Memcache. So this leads into, and I get a lot of questions on this right up front, is multi-data center, and particularly with respect to auto-failover. So you can absolutely have 2 data centers in a cluster, and have some nodes in colo A and some nodes in colo B. But the thing you have to realize here is that if those clusters are those nodes, the 2 data centers are weighted equally, meaning they have the same number of nodes, then if the link between those 2 data centers goes down, you will have a split brain situation where neither component, neither data center, the remaining nodes will have quorum, and so they will both go into the non-primary state. So you can add an arbitrator, say on one of the nodes that you prefer, and if you have, say, a primary, you're just trying to implement maybe a disaster recovery data center, then maybe you start up an arbitrator or an extra node on your primary data center, so you have more weight over there. If colo B goes away or if the link goes down, colo A does continue. But realize that if colo A is the thing that goes down, colo B will not automatically promote itself. It doesn't know how. It doesn't know if it's safe to do that. And so it can be done, but it's a manual step to do so. So if you want true automatic failover in both directions, then really you need 3 data centers. And the third data center could just be arbitrator nodes, or it could be a full data center with actual data nodes. When you get to this level of thinking about cluster organization, the node counts in the individual data centers don't really matter a whole lot. It's really more about, okay, we have 3 data centers, that's what's important. The node counts in the individual data center really just depends on how many nodes you want to have available there for capacity reasons and for HA in those data centers. Realize also, if you are leaning this way, that in Galera 3, in PXC 5.6, introduce something called WAN segments that optimizes cross-WAN replication. It basically sends it a copy over the WAN links once instead of for every node. And it does smarter donor selection. So let's jump into some operational side things about the cluster. What gear, what hardware should I use? This is a common question. So really, there's not a specific answer. This is not a cluster product that ties you into, requiring, tens or hundreds of thousands of dollars of gear. This is standard MySQL NODB for the most part. Galera does use a little bit extra memory, so you may want to factor some of that in. But beyond that, there's really not any other major significant differences in what I would select over what I would select for a standard master-slave setup. Writes are, remember, as fast as the slowest node in the cluster. So if you do put a junker node in the cluster, realize that it can affect all of the nodes in the cluster for write performance. You can tune that flow control, that replication feedback loop that I talked about, independently on every node. And I've seen people do that where they have one node that they use for backups. They tune the flow control really high so it's tolerant. But there still could be some circumstances where that's problematic. People do use VMs. You can use VMs on the cluster. I've seen many situations where the VMs that are, or containers that are improperly configured as far as over-provisioning cause a lot of VM stalls or container stalls because there's something else running on the host boxes that are taking up a lot of resources. And the cluster has issues with that because the cluster is very sensitive to network. It's very sensitive to the performance of other nodes in the cluster. So you may find that things, again, that run fine master-slave, you have a few hiccups, but it's no big deal. In the cluster scenario, may be a lot more sensitive to those types of problems. Just to give you an example of what a configuration looks like, and this is really just to set the expectation that a PXC node is not really all that different from a standard node. We have all this standard configuration that we use in a my.cnf file, and we add some settings for Galera. Specifically, they're the WS rep settings. And if you have a server running the PXC server package without any WS rep, it's going to behave just like a standard Percona server. And it's easy to kind of migrate to the cluster, migrate out if you need to. This is a working configuration, by the way. Communication in the cluster happens over there's actually 4 ports that are involved. The first port is just standard MySQL, so 3306. There's the cluster replication proper is known as GCOM, group communication. That's on port 4567. It does support multicast, it does support SSL, but it's unicast and unencrypted by default. The state transfers each have their own port. SSTs on 4444, ISTs on 4568. All these ports can be changed, and it is possible to configure every single one of these ports to run on a different network. Practically, most people either run everything on a single network, or they have a front-end network for MySQL client and a back-end network for all the Galera stuff, and both are quite easy to set up with PXC. Managing individual nodes, like I said, a node without WS rep just acts like a standard MySQL server, standard Percona server. A node with cluster options is managed for the most part just with standard start and stop in your init script, start, MySQL stop, that type of thing. The WS rep cluster address setting that I showed on a few slides up on the example configuration just instructs the node where to find an existing cluster member. So if I say start, it's trying to go find an existing cluster node to join up into the cluster. But that setting doesn't define the cluster. The cluster defines the cluster. So more nodes can add or whatever. You don't have to go update. That setting is not a source of truth. It just helps get the node to the cluster. Now, if you're starting up the very first node in a cluster, that must do something called bootstrapping or be bootstrapped, which is sort of a special start. but it's basically the same idea. You're starting it up and you're telling it, hey, you can become your own cluster of one. And the data that's on that node becomes the cluster data. So any other nodes that join after the fact will get a state transfer of that node's data, and that's how the data will be propagated around the cluster. So, but managing the MySQL is very much like just standalone MySQL or Percona server. To maintain the cluster, well, standard rolling restarts are pretty straightforward. You just stop a node, it gracefully leaves the cluster quorum count goes down by 1, for failover purposes and so forth. And then when you restart it, it reconnects, it tries to pick up where it left off and do an incremental state transfer. If you need to do schema changes on your cluster, by default, as I said, if you issue a DDL, that will do something called TOI, which is total order isolation. And that's the thing that blocks all the replication and does the DDL on all the nodes simultaneously. You don't have to use that, though. That's just the default, and it's frankly probably what you would expect if you're going to run a DDL command. But what you can do is change that to something called the RSU mode, which is rolling schema upgrade. In that situation, the DDL only does not replicate. So if you have a node in RSU, you issue a DDL, it does not replicate that DDL. Secondly, it permits the node to enter what's known as a desynchronized state. It's still part of the cluster technically, but replication is just queuing up, and it doesn't issue flow control. So that happens while the DDL runs, while the replication is blocked by the DDL. Once the DDL is finished, it catches up, it tries to catch up with the replication, and once it's all caught up, it resynchronizes. So in that situation, you would do the change on one, and then do it on the next one and roll all the way around the cluster one at a time. But that change that you do to the table must be backward compatible replication-wise. And what I mean by that is once you make that change on the first node, you'll have one node that has a new version of the table, and all the other nodes will have the old version. And all of the writes are happening, presumably, on those other nodes. And so if those writes, if the replication events from those other nodes are not compatible with the new table, it won't work properly. Another option for schema changes is PT Online Schema Change, which is another Percona Toolkit tool. This works pretty well and breaks. It doesn't do DDLs that are large. It does DDLs that are small and populates the new table as it's making the change in transactions, which is more friendly with the cluster in general. Now, if you have a non-primary cluster, remember the situation where node C was disconnected, and let's just say A and B were actually down, or let's say you have the two data centers and your primary data center goes down, you want to promote the data disaster recovery site to primary, you can do that manually. You can just connect to one of the nodes and issue a command that tells it, hey, you can bootstrap. But it's up to you at that point. The reason why the cluster is in that state is it doesn't know what to do. That segment doesn't know what to do. It's not sure if it's safe to promote. And so if you're promoting it, it's up to you to decide to make sure that there's no other primary component out there. If you have clusters split into fragments and both are promoted to primary, you now have two databases instead of one. And you probably don't want that. For monitoring, there are a series of global status variables that are also prefixed with WSRep that you can, of course, just go check. Some things that you probably want to monitor is the cluster integrity as a whole. You want to verify that all the nodes are members of the same cluster. So things like the UUID, the configuration version number, the number of active nodes in the cluster, everybody agrees on that. Everybody's in a primary state. And then as far as the local node status goes, things like, is flow control running? Is this node a donor or in a desync state? Or is it in a sync state and normal? These are things you probably want to monitor. There's some more information in our XtraDB cluster manual on that. To give you an idea, from a real-time perspective, this is an open source tool that I wrote called MyQGadgets. I use this a lot, and I do a lot of changes to it. If you've used it in the past, you'll notice it's probably got some new things in it. But basically, this is showing me node status on a second-by-second basis, particularly about Galera settings. So I can see that this is a 3-node cluster. Well, it goes from a 2 to 3-node cluster. I can see the node become a donor. I can see the node causing flow control. I don't have time right now to dig into all the details of what this shows, but this is a way, and very useful way, to see in real time what's going on a given cluster node, and I usually will fire up Windows with all of these, with all the nodes in the cluster and run one of these so I can get a visual of what's going on. There's also plenty of graphical tools and things. An example of that is cluster control by several nines. Cluster control supports both MySQL and DB clusters, but also Galera and some other things. This example has a nice graphical dashboard that shows us the overall throughput on the cluster. The queries coming through. Down here we can see the individual node status, the individual nodes that are in sync in the primary state, and so forth. So there are other alternatives out there. We also have some templates for Cacti and plugins for Nagios and those sorts of things do exist. Finally, on operations, from the perspective, again, of the application to cluster, high availability tools. How do we manage the connections from application to the cluster? How do the applications, how are they abstracted from the complexities of knowing which cluster node to use? Number one, just make sure that you're using proper health checking. You're checking the individual node status. Does the health check respond properly to nodes that go into a donor state, particularly because the donor states can block, or nodes that are in the non-primary state? Can the tool do load balancing if you need it? So some very popular choices that people implement, or some choices in general, I'd say the more popular ones are probably at the top, would be virtual IPs. You could have one or many managed by KeepAliveD or Pacemaker. A lot of people use HA proxy or hardware load balancers, which are pretty much the equivalent of HA proxy on the software side. You can also implement this on your application layer. Things like MySQL ND MS and PHP, can theoretically be used to and even health check properly on the PXC nodes, so that the application just works through the library. And then there's other tools out there like ScaleArc, which is an L7 MySQL proxy. Very cool piece of technology. It is commercial, but it has a lot of interesting features, and that can also be a very useful tool for you as well. So there's a lot of choices there, and it really comes down to the specific requirements of your application, which is one of the reasons why the cluster itself isn't really concerned with that. There's plenty of good choices out there that can meet different people's needs. So how would we actually convert a single MySQL server or a standalone MySQL setup to XtraDB cluster? Well, if we're, sorry, I went the wrong way. So if we're starting with a single server, and I apologize, I have a slide bug here. If we're going to migrate just a single server, say this is a test server in your dev environment or something like that, really it is really just as simple as stopping MySQL, replacing the MySQL packages with the Percona XtraDB cluster packages, add some Galera settings to the my.cnf, and then you start up that node in a bootstrap way, and there's a specific way to do that. This sets up a one-node cluster. That node's data is the baseline for any other nodes that you join into it. And realize when you do a bootstrap on a single node, it's really easy to roll back. You just, put the old packages back in, take out the WSREP settings, and you've migrated back. It's not destructive to the data directory. So the first node, when you do a bootstrap, it's just taking whatever data is already there. Now, if you add other nodes that connect up to this first node, any node that's doing a state snapshot transfer, because it's joining a cluster and the cluster is saying, hey, you need my data, it's going to clear its data directory. So be careful of that. But the first one that you do should not do that. It's very much, of course, easiest to come from Percona Server to do this. And if you are doing this in a test environment specifically, make sure you at least have a couple nodes so that you can get a feel for the latency overhead of commits on Galera. Another method, if you're going to migrate, you just have a master slave setup and you want to just transform it into a cluster in one shot, and you're confident that all the nodes are in sync, indeed, and there's no discrepancies in replication or consistency across the master and slave, then you just take a quick downtime, shut everything down, stop all writes in the application, wait for replication to catch up, break all the replication, so reset slave, stop MySQL. We replace our software as before, we add our WSREP settings. Then we bootstrap our first node, so maybe the master in this case, we start up as our first node with the bootstrap. And then the other ones we add an extra configuration, WSREP SST method skip. So the new nodes will join the master, one of the slave nodes will connect in, join to the master. It'll say, oh, I need an SST, but we can fool it and say, hey, you don't really need an SST. And it will just join, and as long as the data is truly consistent, you should be okay. So you join both slaves, you skip the SSTs, so this should be pretty quickly, just restarting the server. And at that point you've had a 3-node cluster. Just make sure that you don't leave SST method equals skip in production, because you want it to be able to SST when it needs to. So that's another option. Of course, that requires downtime. The third, more of a production way to migrate to the cluster, would be to make a cluster out of a single slave to start. So we take a single slave out of rotation, we transform it into a, say, a cluster node of 1. We add the log slave update setting to that node so that writes coming from its asynchronous master go to any other nodes in the cluster as they are added. And we just test it, make sure it works, add a couple more nodes to it. You know, hey, is the cluster good? Do we understand how it works? Is it stable? Is it handling the read traffic okay? And you know, at some point we just cut writes over to that from the original master. And then we can, of course, incorporate the old master into the cluster. This also works well if you've got, say, you're going to do a hardware refresh anyway, you're buying some new gear. You can introduce that while the old gear is still in place. This works well in that situation as well. Now, the only thing about this is what about rollback? Let's say you cut writes over to the cluster. Is that really the point of no return? Well, not necessarily. So you could theoretically have that node in your cluster that's replicating from the master also replicate back to the master. So if your application flipped between the cluster and flipped between that and the master, theoretically all the data goes in both directions just fine. And if you have any cluster issues on the cluster, you could always flip back. You, of course, wouldn't want to do this permanently, but if you were nervous about how well the cluster was going to perform, or anything about the cluster stability, or the replication conflicts and those kinds of problems, this might be a way to do it safely if it works well for you. So what are my recommendations for migration? Well, evaluate your workload very carefully. Make sure you understand how the replication works. Make sure you understand how things perform, particularly in a cluster with the extra latency of commits. Be prepared that there are things that are operationally different about the cluster than standard master-slave. So in particular, make sure you do plenty of HA testing on the cluster, lots of fun pull-the-plug type stuff. Make sure you understand how that cluster behaves in circumstances, and make sure you know what to do. How do you, rebootstrap a cluster? How do you promote a non-primary component, and so forth. Generally, I would say stay with a single writer when you're migrating, particularly an existing application. Avoid major MySQL version upgrades at the same time as a migration, because you don't want to be blaming, problems that might come up from, say, going from 5.5 to 5.6 on Galera and vice versa. That's just about reducing your risk. Try to do many changes at a time, and then possibly dual master your cluster with the old master for a rollback method. So some resources that may be helpful for you: the Percona XtraDB Cluster homepage contains a link to downloads and also to our manual. Galera documentation can be found at Codership's new site, which is galeracluster.com, although I would say our documentation, I think, has pretty much a superset of what's on their site at the moment. I wrote a Percona XtraDB Cluster tutorial that I give at conferences, and that is open sourced on GitHub, on Percona's GitHub page, so you can go through that in a self-guided way that uses Vagrant, if anybody's familiar with that. We have plenty of blogs on PXC and how it works on our Percona MySQL performance blog, and there are also some good Google groups that discuss Galera. Specifically, I would say the most popular one for Galera discussion is Codership team, but you can also ask Percona discussion. So with that, I will open it up to any questions that you may have sent to Terry.
Okay, thank you, Jay. Again, everyone, if you have a question, please enter it in the chat window in the GoToMeeting control panel, GoToWebinar control panel, sorry. And also, we are recording this webinar, and we will send a link to the recording once it's available online, so look for that in your inbox. So we have a couple questions so far, Jay. The first one was actually entered before, at the very beginning of the webinar, so maybe you could just expand a little bit on how one configures replication of 2 data centers in different countries.
So as far as Galera and PXC are concerned, for cross data center, for the most part, the nodes are just like in data center nodes. All the nodes have to have a WSREP cluster address. They all need to be able to communicate with each other on those Galera ports that I mentioned. So the 4567, the 4444, the 4568, that all needs to work, and it's assumed that they can all talk to each other and recognize each other in that way. In Galera 3 and on Percona XtraDB Cluster 5.6, the only thing I would add to that is that there is a way to configure those WAN segments, so you can identify to the cluster, this node is in data center number 1, this one's in data center number 2, however many you have, and it will automatically sort of manage some of those WAN segment optimizations that it has. So the configuration across multiple data centers is really not all that different, but of course it will add latency to your commits, and it will, there's potential networking concerns and security concerns even that you may have with replication cross data center.
Okay, the next question is, how would you recommend performing a daily complete dump and import of a database for QA purposes? It seems this import would cause a large amount of synchronizing within the cluster and potentially cause issues.
Mm-hmm. So a lot of people who are doing operations that are potentially harmful to the cluster, depending on how you do a MySQL dump, that may or may not be the case. If you're using the MySQL dump single transaction, it shouldn't block the node that you're backing up, but it might, add enough overhead to the node that cause other issues with the cluster. The way a lot of people address that is they simply have an asynchronous slave of the cluster that they use for those type of purposes. And common use cases for that kind of slave are backups, are data warehousing type queries or ETL processes that they know are heavy on the node, but they don't want to have it affect the production main cluster itself. So that's really the beauty of having a mix of the synchronous replication for your really sensitive real-time type purposes, and then an asynchronous replication to something that you can hammer on a little bit without having any real direct impact on the production cluster.
Okay, the next question is asking, can you shed some light on Gcache in cluster, and how you would calculate the exact size for Gcache?
Okay, so Gcache is effectively the thing to think about with Gcache is that it's the cache for IST. And if I go back a little bit here, let's see. In my latest version of MyQStatus, and if you run this on 5.6, you'll actually see the number of transactions in the Gcache. That's this column right here, the number of transactions. So right now you can see, like at the bottom, there's 3,028. Functionally, what you need to understand is that Gcache helps you optimize things so that you IST instead of SST. The state snapshot transfer is heavy; it's a full backup of the donor node, while IST is just, hey, give me the set of transactions that I missed. So obviously, the larger that is, the longer you can leave a node down and then start it back up, and it will still IST. How big should it be? Well, if you use my example, I have a write rate here of about 10 transactions a second. My Gcache at the moment is holding 3,000 transactions and probably can hold a lot more. You can do some math there to sort of figure out with your workload, if it's already set up and the Gcache is populated, this number will start to be kind of constant. And you can figure out, well, I have an hour, or I have a half an hour, or I have 6 hours, and make some adjustments there. I don't think it really, I think if you're overly afraid of SST, that you might want to be careful with the cluster. It is possible to, like SST, you shouldn't be too afraid of it, I guess is my point. And if you're overly concerned about the Gcache, then you're probably afraid of SST. And if you're afraid of SST, your database is probably just too big, you've got way too many tables, extra backup is way too blocky for you, or whatever. There might be some ways to deal with that in a more manual fashion to trick SST and do manual SSTs, but I'd also want to consider, is this just a good fit for the cluster? And do I have enough data nodes so that when I have a donor, it doesn't affect my production use?
Okay, next question. Is there a problem using stored procedures in the cluster? For example, creating temporary tables inside a procedure?
Mm-hmm. So stored procedures, the replication for a stored procedure, remember that everything inside of this is role-based replication. So any change that you make to the node that runs the stored procedure is going to generate a set of RBR and that is going to be replicated as a transaction or a write set inside of Galera. So practically speaking, using stored procedures should not be a big problem. If you are generating a temporary table and then selecting from that temporary table and inserting into a regular table, that insert into the regular table should be what generates the row-based replication, and it should not be an issue. So practically speaking, things like triggers, stored procedures, and those sorts of things behave just like if you're using asynchronous replication and you're using row-based replication. And in that case, it does not replicate the call to the stored procedure, but it replicates the changes the stored procedure made, if any. So it should be safe.
Okay, next question. Many examples use 3 as the number of nodes. How does this scale to 5 or 9 or 17 nodes, for example?
So as I mentioned on some slide or another here, the performance of the replication will degrade as you add more nodes. And I'm trying to put together enough data to write a blog post on this. I can't find it. But so, you know, by default, it's all unicast, a single thread. The client thread is sending the replication event to all the nodes in series, and so there's a little bit of overhead every time you add another node to it. You know, 3 to 5, as I said, I've seen 3 nodes, 5 nodes, I think up a few more, but nothing much more than that. And I think the real question to ask yourself is, what is your use case to have 17 nodes? I mean, what are you trying to accomplish there? If it's data distribution and you have literally 17 data centers, or you know, you have 9 data centers and you want to have a couple nodes in each or something, I could see that. But if it's really read scalability, you might be better off having a smaller cluster and then either having asynchronous slaves of that cluster for read scalability or memcache or something similar of that nature. My sense would be that that would scale probably a lot further for you, but of course it depends on the use case.
Okay, next question. Are there any issues with replication of memory tables?
Memory tables are not InnoDB tables, and therefore they do not replicate across Galera. So you should not be using any types of tables in Percona XtraDB Cluster or any Galera cluster apart from InnoDB tables.
Okay, next question, Jay, for you specifically. The question is, will you be giving the hands-on XtraDB class you gave in San Francisco earlier this year anywhere else, like Chicago?
I would love to hear votes with people who would say can commit. They say, yes, I would love to come. The more of those I have, the more likely it is. But our planning for 2015 training is happening very soon, and I frankly don't know at this point. I think whatever happens, you know, I think there's enough demand for that. That training is really based off of my conference tutorial, and it is a significant undertaking to give. But I think the people who attended it really liked it. But it's a lot of work, and it does cost a lot to do it. So I don't have any firm plans for that at the moment. But I think with the right, you know, amount of people really clamoring for it, we could probably justify it.
Okay. Well, it looks like you have at least one vote for Chicago right now.
I've heard Chicago.
Next question, and if anyone has any more questions, we've got about 2 minutes left here, so please get them into the chat window. Next question is, are TalkUDB tables making their way into the cluster?
Yeah, good question. So we would really love to see this. Codership has done some proof of concept work with incorporating Toko. What you have to understand is that the implementation is not just on the Galera, side of things, but it's actually within the storage engine itself. For example, the reason why there's an extra version of the server package, the MySQL package, is because they implemented a lot of patches into MySQL for things like the status variables, but also patches into InnoDB to support specifically the big thing is something called prioritized transactions. The replication conflicts that can be generated by the cluster require that you can set a priority of a given transaction over another transaction. And by default, InnoDB doesn't have that. Neither does TokuDB. So TokuDB has a lot of good things going for it, though. It is transactional, and it's in Percona server now, and the Toku team, who maintains the code base for the storage engine, is interested in Galera support. So I have very good hopes that this is something that we will see, but I think a lot at this point, the development of that, the core pieces of the development of that are relying on Toku specifically, the company that supports TokuDB.
Okay, very good. Well, we're at the end of our time here, so we do have some additional questions. So we'll pass all the questions to Jay, and he will answer any unanswered ones in a follow-up blog post to the webinar. Jay, thanks for your presentation today. Again, we have been recording this, and we'll send a link to everyone. And if you would like to learn more, and you're in Europe, mention that Percona Live London is coming up at the beginning of November, and the Codership folks will be there giving a keynote, as well as the Percona staff will be attending. So that's great chance to meet face-to-face with a lot of the folks involved with Percona XtraDB Cluster. And with that, we'll wrap it up. Thanks, everyone. Have a good day.